Uh, okay, I think most of us has joined up. Hello again and welcome to this webinar one more time. Now we will go ahead and start our presentation. So as we said earlier, the topic today is how to combine photogrammetry and traditional measurements in one 3D model using breakline support. So today, the topic today is more of a hands-on topic. So there will be less theory and more practical approaches. So we will be looking at 4 examples. First one, we'll be looking at workflow on how we can triangulate surfaces from CAD data using breaklines. So this will be just the initial presentation in order to give you an idea what is possible. Then for the second example, we will look at how we can fill in point cloud holes by triangulating survey point data. Example number 3 will be advanced surface construction. So we'll be looking at slightly more advanced functions on how to generate 3D surfaces from either survey, total station, GPS, or point cloud data. And for the last example, we will be looking at 3D area functionality. So how we can measure 3D areas. In our example, we'll be looking at 3D areas of the roofs, but this applies to anything. Okay, so let's go right into our first example, looking at how we can triangulate surfaces from CAD data. Just 1 minute. Let me just check one thing before we go. Okay. So here I already have a data set prepared for that. So this example was shared by one of our customers. I think it was about a year ago or so. So, and this is example of something that most of our customers face when we are calculating volumes. So it will happen quite often that we will get some old data. Now, in this case, we have here some 3D lines and 3D points for this quarry site. So a customer made a point cloud of a quarry here. So his job was to measure volumes, but he didn't have the initial surface. So because of that, he used some old survey maps that he got from his client, and those old survey maps, they included some breaklines and some 3D points. So from the survey map, he also used the 3D contours that were available. So now, since the version 2.13 in 3D survey, we have a function that's called triangulate CAD data. So he loaded these breaklines, 3D points, and contour lines into 3D survey, and then using mesh triangulate from CAD data, we can convert these points and lines into a 3D surface. Let's have a look at how this works. Let's go to mesh, triangulate from CAD data. So here we select which layers we want to use. By default, all of layers are selected, so that's fine. We want to use all of them. Press calculate. Now here we really have a lot of lines and a lot of points. Because of that, this triangulation will take about a minute or so, but for smaller data sets, this would be faster. So what happens in the background? The Looney triangulation of the points and endpoints for lines is used, and then in the end, the break lines are also used as constraints for the final surface. So the result will be a triangulated 3D mesh that we now already see here. And it was made using the definition in CAD file. So this is now our 3D mesh. We see now, because it was made from this CAD data, it looks pretty sharp. So now this is our 3D mesh. So the job is then to compare that mesh to our point cloud. So this is the point cloud. So this is the mesh for initial version. Let's see what the point cloud was like. And this was the point cloud that was taken now at the time of measurement. So the job of the surveyor was to compare the initial 3D mesh to the one from this point cloud. So we will now really quickly just create another DTM from the point cloud data, mesh, calculate new regular grid mesh from the point cloud, 1 meter grid size resolution, press calculate. We have just made this DTM. Now, if we turn this one back on, if we want, we can use this one to calculate volume. We'll do that just really quickly now. We'll go to CAD, we'll define a new layer, 0, 0, volume, boundary, make it active, bright red color. And I will draw the outline real quickly. Just for now, we'll just snap onto 3D mesh only, just so that it will display faster. So if I were doing this for real, I would click way more accurately, but for this example, right now, I'll just draw the outline like so. Okay, now we have to turn on snapping onto endpoints, not points, like that, in order to close the line, like that. Okay, let's go to mesh, calculate volume. So initial surface will be this triangulated mesh, final surface will be surface made out of point cloud. From CAD, the boundary, now we have to deselect all of this and leave only this one, 0, 0, volume boundary, press calculate. Wait a few seconds. And here we have our volume calculation. Okay, we'll just leave the name at default. Press OK. So here we now see the surface of the difference. So the blue values, they tell us where the material was excavated from the site. So this will be fine. Okay, then when we are making this kind of volume calculations, usually we will also need some vertical cross sections. Now, in order to calculate a vertical cross section, we will need a point cloud. So in order to display the difference between these two surfaces nicely, what we need to do first is go to mesh. And now we will convert this triangulated mesh into point cloud. We do that by clicking on triangulated mesh, selecting convert to point cloud. Let's use 100 points per square meter. Press calculate. So it will just take a little bit of time as usual. Let's go here, turn off point cloud and mesh like that. So here we now only have point clouds, and also this CAD off. Let's go to volume, turn off the volume off because we don't need it right now. Go back to point clouds. Okay. Turn off point cloud and mesh as we said earlier. Okay, now here we have that point cloud that was created out of the triangulated mesh. So first thing that we see now, the color of it, it was automatically extracted from the CAD data. Now we want it to come in nicer, so we will just right click here on triangulated mesh and select here option height map. So this is also one of the new functions. Now you can change display mode for each data, for each point cloud, for each mesh, for anything. So right click on this one and use height map on this one, like that. With shading, it will look even better. Okay, and so the initial point cloud was triangulated mesh. Final one was the point cloud. We can also change the order in here like that. So now let's make some vertical cross sections. So I'll go here and I will just draw a few of the profiles. Select profile definition line, and the first one will go from up here to down here. And the second one will go from up here to down here, for example. Now let's go into profile view. And just like normally, also now here we have now the red is profile calculated from the point cloud data from our drone survey, and the purple one is calculated from triangulated mesh data. So here we see we have some difference between the two, but of course the red surface is newer one, the purple is the old one. So of course the surfaces change slightly, and we can now see clearly how much the quarry site was excavated in that 1 year or so. And then we can use this data in order to make a report just like we would or usually. So let's see, we have some orthophoto for this example, load. We have something. I'll just load this one in. Then press project, generate report, measurements report, and we can select which volumes, which profiles to use in our report, and press create. And as usual, that will just create a Word file with the volumes and vertical cross sections in it. Okay. So this was example 1. This was the introduction to breakline support. Now let's move to example number 2. How else can we use these breaklines and triangulate CAD functionality? I'll just cancel this one and we will just minimize this window of 3D survey. Now let's continue to example 2. Filling in point cloud holes by triangulated survey points. What do I mean with that? So here I have a second example. So this is the data set that we like to use quite often. So here we have this small excavation site. Now this is the classified point cloud, and a part of our area of interest is covered by forest. So before we didn't worry much about the forested areas, but with the newest functionality, we can try to fill in the areas like this one, where we don't have any points. So what we did here, we went out and we surveyed some points inside of this whole area. So now I'll go to CAD, I'll use data load CAD, and I have here a txt file with some points of this, some GPS, I mean total station surveyed points. Select this, press import. So these are the terrain points that were surveyed with a total station. Now we will make a surface out of this one, but before we make a surface, we will also add some points here on the terrain. So in order to expand them, so let's color these, for example, blue, and we'll also make a new layer, points from point cloud. You'll see in a minute why I want to add additional ones like that. Okay, because here we only have points at the top of this hill. We will now also add some points here at the bottom of the hill. Let's make this, let's say, yellow. Okay. Because we will add these points, because we want the point cloud to connect as best to our point cloud data. Like that, I'll just add them in real quickly. So here we actually already have some hill information. Also add some points here. Okay. And before we go and triangulate these points, an important step will be we need to connect the break lines. go here like that. So what we need to do, we need to draw the break lines. So break line is a line where the terrain breaks. So I will use draw line and I will connect the break line 1 like this. So in order to snap on the point, it's best if you try to put the mouse onto the number, point number or height, like that. If you make a mistake when you are drawing line, there is an undocumented function. If you just press backspace on the keyboard, that just deletes the last point that you made, like that. Perfect. Now the other one. Okay. When connecting line, if you forget a point like this, like I did now, also we have a function for you. Select a line, double click on the line like that. That places a new point here, and then you can just move that one here, for example. Okay. Now there is not much left to do. Let's make a surface out of our points. So let's go to mesh, triangulate from CAD data, use all CAD data that we have, and bam, we already have our surface. Let's see how that fits to our point cloud. So this is the surface that we just generated. Now, okay, what we need to do now is, okay, it looks fine, that's fine. So here an important step is just to check it out and see if there is anything that doesn't make sense. We could add some break lines in and fix it. So for example, here we see that we got this unnatural looking triangle. So probably it would be better if we add an additional line here and we say, okay, yeah, the triangles should actually go like this. So here they already go, but this one should. So I don't like this triangle here. We can add a break line, for example, here and break that triangle. Delete this mesh. Triangulate from CAD data one more time. Okay, now it looks better. Maybe this point that we added here, we can also do without. Yeah, it doesn't look like it fits well. So this one we added in the end. We will just select it, delete it. Repeat mesh calculation real quickly. Okay, now I'm happy with the results. Perfect. Now what we will do, we will convert again this mesh into point cloud. Go here, zoom in, turn off point clouds and meshes. Change the displayed mode for this one again to height map. You see here we have slightly different height map color. If you want to change the colors of height map, there's a trick to do that. So we just turn on height map, double click on it. For example, we'll use this one, this color, turn it off, height map off, and turn only height map on for this point cloud. Like that. What I want to do now, before I join these two point clouds together, I want to trim this one slightly. So I want to delete this point cloud where I have enough photogrammetric point cloud definition. So let me show you how to do that best. So here I will just select, before I do that, let's increase the point cell size slightly. And actually, in this case, it will be helpful if we set custom colors to our point clouds. So for example, we will set the color of our photogrammetric point cloud to, let's say, light blue, okay. And we will set the color of our triangulated mesh to light red, which okay, orange. And turn off the height map like that. Clear, and now we will use select tool to delete the triangulated point cloud. Let's rename this one to triangulated point cloud, where we have the photogrammetric point cloud definition. So you select. In this step, we will just select both of them like that. So there where we have blue points, we will select this point cloud like that. So these are now the selected points. Turn off temporarily the photogrammetric point cloud and now use delete selected like that. Turn this one back on, clear, and that's how we deleted this point cloud where we had overlap. And then we just continue, just press clear, select, and again, just repeat the process. Turn this one off, delete selected, and this one back on. Like that. Okay. The other side looks pretty okay. And now what we can do, we can make a digital terrain model from both of them. So what we will do now, we will merge these two point clouds. And now we can make, so, okay, now, funny thing, this old one had point clouds, so let's send it off like that, and this one off. So now on the merge point cloud, never classified points are the one that were from triangulated surface. Unassigned are the non-ground points. And these ones are here. So when we will be making our digital terrain model, we will make it out of these 2 point classes. Let's go to mesh, new regular grid mesh from never classified. So this one is actually points from triangulated point cloud. And we want to use ground. Press calculate. And we now have our regular grid mesh that has also this part now well defined. And this is how we can now combine the data to make more realistic point clouds even for areas under the forest, so the things that were not possible before with photogrammetry only. So here we showed how to join in the points measured with total station. But these points could be measured with any similar technology. We could also achieve similar things from if we added just LiDAR data for this area. Okay. So this was example number 2. I think we are making good progress. Let's go back to our presentation. And let's look now at our third example, advanced surface construction. So let's see what more we can do with the break lines. So here I already have opened our third project. So again, we have here a photogrammetric point cloud. Now I want to show here, so this is also something we get questions about. So here we see we have some material here on this side. And so our material here is placed at a surface here that's at an angle. So here our customer wanted to measure the volume of this material here, but he wanted to measure it against this area here. So you see we have here a wall, and the wall goes down sideways. And here we have the material that we want to measure the volume of. We can now use the triangulate CAD data function to generate the bottom surface for this kind of area. So how do we do that? So we will go into CAD and we will draw the boundary of this area of interest. Like here, CAD, and we'll just name the layer CAD surface, for example. Okay, and I will just quickly draw the outline of this file. Okay, so here it actually goes here and down here. And here we go up on the shoulder like that. And down here. So now here we have this shoulder. Let's edit this a little bit. I think this would be better if we set it like so and move this one down like so. And here, this one, the shoulder, I think it starts here like that. And this one down as well. Or actually this volume, it goes here actually. Like that. So here in this case, we will want to add break line like so. Okay, and now to generate the bottom surface, we will just triangulate this data. And we have here our triangulated 3D mesh. Here it is. Turn off the point cloud temporarily, or just turn off point cloud meshes. So that way we were now able to generate our bottom surface using this break line. And then if we want to calculate volume, we can now calculate it nicely here. So what we will do now, mesh, triangulate. We will just make a regular grid mesh out of ground only, press calculate. Now calculate volume. So initial surface will be triangulated one, final surface will be the photogrammetric point cloud. We already drew the boundary, so we can reuse that boundary from CAD. On this CAD surface, we have the closed boundary, and we press cut. It says no lines found. Let's see what the problem is. I guess the line is not closed. Yeah, I didn't finish and close this closed. It's on the default layer. That was the problem. Calculate volume like that from CAD. It's on this layer actually. Press calculate. Now it automatically selects the area and it calculates the volume. And so here it correctly takes the lower surface into account. Well, I guess that's the best guess we can make if we haven't measured the lower surface. Now, here I just want to show a few additional stuff. So here we have another example of a material pile. So I'll just go ahead and I will make a copy of this mesh. I'll just go mesh, calculate new regular grid mesh, just like we did. And this one we will rename custom, or we will rename it manipulated mesh. So quite often it will be the case that when calculating volumes, we need to calculate volumes from certain elevations. So for example, our clients will tell us for initial value, take the height, for example, 455 meters, and calculate the volume difference, how much material is here above that height. So in order to do that, we can use the manipulate point cloud tool or manipulate mesh tool. So we can just make a manipulated mesh. So here we will just select now the area of this pile of material. Like that. And now we will use manipulate points function, set height 2, and we'll use 455. Press OK. And we have just generated a flat surface with that altitude. Now, in order to calculate this volume, we just press clear here. We'll just move the order like so. Select an area like this. And add this one in also. Now press calculate volume. So initial surface will be the manipulated mesh, final surface will be our original mesh from current selection. And now we also have this volume, and we got how much the material was here above the height of 455. Press clear. Now for the final example here on this manipulated mesh, let's turn off point cloud and meshes. I just want to show one more functionality that's, let's also turn off volumes. So that's calculating the average height mesh and why this one is useful. So let's say that I'm just trying to find a nice pile of material. We will use this one here now. For example, here we have now this kind of file. So let's just remove this. Let's just prepare this one slightly more. We'll flatten this area here, like so. Add that in, also flatten again. We're just preparing our data. So here we have a pile of material, and let's say we want to level our terrain. We want to make it flat. So we can say if this is our area of interest, and we take a steamroller and we make this area flat. We don't want to add or remove any material from the site, what height of the terrain we will get. So there is a function here under manipulate points. It is under average height. If we press this one, we get average terrain height. So that means if we flatten an area, we remove the terrain, we move the terrain so that it's flat. This will then be the height that we will get. It will be 455.6 meters. So the height of the terrain will be, in this case, about 1 meter. And we can also use this kind of terrain for calculating volumes. Okay, this manipulate mesh functionality, the same functions also work on point cloud. So you could also select the point cloud here and then go here to manipulate points. So here you see you have options set height to, so that means set the height of this point to a certain value, increase height, average height, or more. So for this example here, we will set it to average height. So this would then be the height of the terrain if we just flattened it and we haven't moved the terrain here to or from the side. Now, one final thing that happens very often when we do this kind of survey and we need to make surfaces. So it will happen that when you will get to the terrain, when you will do the mapping, the construction company there will say, okay, so here for this area of interest here, we still need to excavate 2 meters of the materials. So you can also use this select tool on point cloud, use manipulate points, use increase height, and say -2 meters. For example, like so. And you can move the points vertically like that. And if you do that and then write into the report based on the information from the client, here we lowered points by 2 meters because their additional 2 meters were excavated. And that way we can also take those information into account. So, okay, so these were some examples on how we can manipulate points and surfaces using manipulate points tool and how we can use the triangulate function. Now, for the last example, real quickly, I want to show additional functionality, how we can use 3D areas, how we can calculate 3D areas. And to save some memory, I'll close this one just to make sure that we have enough memory to load our final example. Okay, this data set has a 3D mesh and a point cloud inside, so let's just wait for it to load. We don't need the images. Okay, let's wait for all the data to get sent to the GPU. Let's go to point cloud. So here is our point cloud for our area of interest. We also have a mesh, a regular grid mesh calculated here. And we also have a full 3D mesh. Let's just wait for the textures to load. Also, this will just take a little bit longer. I think my memory is just filling up slightly. Let's see how my, okay, we are at 86% of memory full, so that should be just perfect. Clear. Okay. Interesting functionality is also we can use calculate volume function in order to measure the area of roof in connection with 3D break lines. Let me show you the best workflow to do that. So in order to measure the 3D area of this roof, what we need to do is we need to go to CAD. We will create a new layer here, 3D roofs, for example. Make it current. We will, for now, we don't need the point cloud. We can just draw on the mesh. And for each area, we need to, for each roof, we need to do two things. First one will be, we need to draw the outline, so the boundary, like that. So first, we define the roof boundary real accurately. And then we also add in the break line definition, for example, like so. Like so. And like so. So this one will be for roof 1. Let's repeat the process for a second one here. Like that. And we will add the break line up here, like so. Now again, we will use the triangulate CAD data. Okay, so if we wanted this roof down here, we would need to draw this one separately. We would again need to draw the break, the boundary, and break line. And for this one and for that one, and so on. For this example, 2 will be enough, I guess. Go to mesh, triangulate from CAD data. We have the roof definition up here on the 3D roofs layer. Press calculate. And we made this kind of a mesh. Okay, now in order to calculate the area of roofs, we just go here. So now the best approach is, and we'll just name this one triangulated mesh roofs. Okay, like that. Okay. Now the best approach is to also make a digital terrain model, and now we will use the calculate volume function. So now here it's important. For the initial surface, we will use the regular grid mesh called DTM, so digital terrain model. And for the final surface, we will use triangulated mesh roofs. We'll use this function from CAD, and that means it will take boundaries, so that's closed polylines from the 3D roofs layer, and for each closed boundary that it finds, it will make one volume. Let's calculate, and this is how we got two roofs, so roof 1 and roof 2. Press OK, check the volumes, we'll turn off this mesh, go here to volumes tab, and here we have our roof 1, and we have the 2D area, which is slightly under 170 square meters, and we have our 3D area that's 186 square meters. So, and we can check the same thing for roof number 2. So here it is, so this one is closer, the 3D area is about 66 square meters and 2D areas is 62 square meters. So we could check if these values make sense by just checking the, okay, yeah, it might be hard because this one is not square. It will add up but here one important thing to note is, so this functionality was actually intended for measuring the piles of material. So we got the question, okay, how much material we would need in order to cover this pile of material. And this is where this functionality came from. So for example, if we use it here on this pile like that, and also this here, press calculate volume from current selection. The 3D area is always the area of second surface. So here in our example, initial surface we interpolated, so we're never very interested in the interpolated surface 3D area, we're just interested in the final surface. So because of that, here, if you want to use this functionality to measure the roof area, you just need to make sure that when calculating the volume, the final surface is always the triangulated, you will always get the 3D area for the final surface. And because with the triangulated mesh interpolate function doesn't work, it's best if you also calculate the DTM for your area of interest like that. Okay, so I think we are making good progress. It's now 5 to, we are now 55 minutes into our presentation. And now for the most interesting part, let's go to the Q&A session and let's see if there are any questions in our question box. Also, if anyone has a question about anything that we displayed today, now would be the best time to ask that question. So I see we have 2 questions for now. The first question is it possible to smaller the text size for 3D CAD points? Let's see if I have this one still open. So here we have some good question. Thank you for asking it. So here we have some 3D points. If we look at them from distance, their size is pretty big. So what we can do is we can select all of these points at once by clicking on one and then using this select similar or select similar on same layer. If I select similar on same layer, now I only select the yellow points. And I can set the font size for the yellow points only. Of course, I can also select one point and use select similar. That means it will now select all the points. And now the font size is mixed. We can set the font size of 8 to all points like that. Okay. Nice question and a quick answer. Let's go back to our question box. Just how to zoom it in. Can you telemetry for this flight? The last one. So I'm thinking, so Mr. Ferenc is asking if we can show the telemetry for this flight. Yes, sure, no problem. Just 1 second, I'm turning the full 3D mesh on. Our memory is almost full. Because of that, it just takes slightly longer. Let's just wait a little bit more. Okay, so this is our full 3D mesh. Let's show the cameras. So this is how we recorded images. So we, again, probably too many images. We had images at different heights. Here at this height, we had a double grid, and then we also had some manual shots of this area of interest. And that gave us this nice point cloud. Okay. So this was question number 2. Let's check if there are any more questions. I guess not. So perfect. So we are just in time to finish this presentation. So I would like to thank you, all of you, for coming and listening to this webinar. I hope you found it at least a little bit interesting. And that's it. Goodbye and have a nice rest of the day. And see you in one of our future webinars. Bye-bye.